Hello everyone, my name is Shardul. I work as an AI engineer at a startup called Inamdar.
I'm Praveen. I work as a product manager in Red Hat in the application development business unit. And hello.
I'm Praveen. I also work with Red Hat and working with the rubber tooling side.
So hi, this one could be a bit informal also. What we've done is there was another speaker who was supposed to come, Cedric, and then we had to join his talk with our talk, and then we made a mashup of with the slides and talks. But what we'll be covering mostly today is one, working with large language models have become one of those must-have skills right now, irrespective of what your background is, whether you're a developer, product manager, engineer, or finance, anything. But one of the other things what we're seeing is many organizations have been experimenting and trying to adopt large language models, especially the ones like the ones which are provided as a service from companies like OpenAI, Google, and Microsoft, and all of these. They've been experimenting for almost 18 to 20 months now, but many companies have not taken it to production, and most of them have been stuck in experimenting with generative AI. And it's not because of the technology, it's because of the other factors which are affecting them, like how they use it legally or how they use it in a compliant way, in a secure way. Okay? So this has been one of the industry trends, and what we've been seeing is from both the sides, both the hardware of the actual architectures and also the kind of models which are releasing are becoming better and better and more efficient. So if you take a look at the cadence cycles in which most of the large language models were released over the last 18 months. So if you take a look at the time cadence between ChatGPT 3 and 3.5 was about a year, but again between 3.5 and 4 it was just 8 months. So that is one of the examples of a very large funded company like OpenAI. But it's been true across the industry because each and every model is trying to outperform the benchmarks of the previous model in the LLM arenas, and it's becoming faster and faster. So many patterns have emerged when it comes to, let's say, application development and deploying these models to production. So you might have heard, like in all of 2024 was RAG model, RAG pattern, and now we are seeing a mixture of agentic and RAG, because one of the things with the large language models, one way to look at it is they are like mechanical machines. You throw in some input, it's going to throw out some output. And in most of these cases, the output may or may not make sense. Sometimes you might get the answer in the first possible outcome, and sometimes you might get the answer after 3 or 4 tries, or sometimes you might not get an answer also. And what many folks have been, they have been dabbling with in getting these models to production. So because even after doing all the fine tuning and training, models are still hallucinating. So those are one of the things, major barriers in which they are not taking it to production. But another aspect of it is most of the companies don't want to share their training data on public cloud infrastructure in order to consume these models. Because there's always been a platform threat from the major major cloud service providers. So like say, for example, one of the neat examples I gave in India is, like if you want to transfer money to each other now, what do you use? But is Google a bank? No, right? So because, I'm not like because there will also be many other cloud service providers. They not only know your exact technology footprint to run this problem at a scale, they also know the business patterns in which people come, what time they're using it, because you are using somebody else's infrastructure in order to solve your problem. So there's always a platform threat from the underlying players. So what we'll be touching upon is mostly around running local language models, and this has been a pattern which many organizations are adopting. And it's not just innovation around the software side, even the hardware side. Many organizations, like how many of you have heard about how DeepSeek built their model? Okay, because it's under the constraints, because under the export compliances they were not given enterprise grade GPUs, but they had to build their own model with consumer grade GPUs. And this is something which we are going to see more and more. This kind of pattern is kind of repeating in the hardware and the software combination. So if you take a look at when I started off computing, So one of the major competitors for Red Hat was Sun Microsystems. So I remember sitting in the room and seeing, what is the strategy against Sun Microsystems? Because they had a hardware and a software platform built together, and then Red Hat as a company was using CISC processors. These are your Intels and your AMDs, which was commodity hardware which anybody could buy, and try to compete with large incumbents like Sun Microsystems. But if you take a look at it right now, it is going back to the same area where there are specialized chips being built for the specialized problems, and specialized companies who are making these chips would expect all the new developers, either hardware engineers or software engineers, to be proficient on their platform. So in a way, we're getting back to the vendor lock-in system where a specific problem can be solved with a specific hardware, a CPU and a GPU combination, and a specialized memory or a specialized chip on top of these machines. So it is not only the software side of aspects which you need to learn, it's also the hardware, how hardware is evolving. And it's not just in how efficiently you're solving these problems, it's also how efficiently in terms of the power consumption, how efficient you are in terms of placing the right workload in the right server. So all of these are the newer problems which are opened up, and these are the problems which your customers, or even if you're academic, if you have your own clusters inside, these are the newer kind of problems which you are going to work with. And the second major barrier is, if you take a look at it, it's all layers of abstractions which are being built. Maybe if you have done your engineering in late 90s or early 2000s, you might have been actually working on the actual IC circuits in order to solve for an exam. But right now, or whatever, like recently I saw one of this advertisement, you have BTechs in artificial intelligence, or BTech in generative AI, or VE in generative AI. Because every generation of computing, there is some kind of abstraction which is being built. So we started working with microcontrollers, x86, Motorola microcontrollers, and then our generation is a bit different because we were blessed with seeing how the computing grew along with the programming languages and along with open source. But right now, if somebody is trying to solve any problem, now we have prompt engineering as an engine, which will solve the problem for you. That is how abstractions would come. And now, again, you're making that even more efficient. Let's say, from the industry terms, if you're from the industry, you might have heard of terms like business to consumer, business to business. But right now, the way even the consumption of these models are changing is, it is business to agent. So the content what you're generating, the software what you're writing, it might not even be a human who's consuming that software in the very near future. It's going to be another AI which is going to consume that particular software. So these are the kind of things which you need to keep in mind while having said that, most of the modern applications, why we're talking about this product called Podman Desktop, most of the modern software which is being deployed, at least the greenfield ones, as in they're starting out from scratch, at least 50 to 60% of these models are going to be deployed in an infrastructure that has Kubernetes. How many have heard of Kubernetes? Containers in general, right? So most of the modern software applications, as a developer, you are expected to know how to containerize your applications. You are expected to know how to take your applications from your workstations to production environments. So that's where a project, Podman Desktop, comes in, where it lets you develop your applications, puts an abstraction so that you can make containers out of your application very easily, especially if you're deploying it into enterprise Kubernetes distributions like OpenShift or any other thing. You can take this, you can use Podman Desktop to take it to production, not just for OpenShift, any Kubernetes out there. So these are few of the skills, and these things kind of abstract the layers so that you don't feel overwhelmed or complex. You don't feel very complex about, what am I learning. Let's say artificial intelligence has been there from 1970s in the curriculums, and people have been using artificial intelligence in various ways, especially in the gaming world. If you have seen all these bots which play games and various aspects, it's always been artificial intelligence, or in movie productions or various things, artificial intelligence was always used. The form in which it got very popular recently is generative AI, because for the past 20 years, especially in the Python, R and the Julia stack, if you're a data scientist or if you've been learning around data science, those have been around for past 2 decades. But right now, the generative use cases is an abstraction built on top of all the abstractions they had built for traditional AI or predictive AI. And these foundational models in deep learning are the basic foundational models what you're learning. Because you can go to this slide. One of the ways in which developers are consuming deep learning is via generative AI, and this one has been by far the most successful adoption of technology. So, but from the developer's perspective, right, most of the developers are used to working with an API. And because they're used to working with an API, either as a service or locally hosted, they have adopted using generative AI at a rapid pace. Like right now, most of the applications, whether it is for code generation, image generation, content generation, most of you are using some sort of a API interface to interact with these deep learning models. And the most popular way of interaction right now has been a chat-based interface. So any kind of input you're giving or any kind of feed you're giving, it's mostly because that's where the human in the loop is still there in most of these aspects. The other problem is, don't worry that the generative AI is going to take your jobs away or anything, because the kind of content it is generating out of this, there's a lot of human in the loop play still out here. There's a lot of human in the play loop still in the play, let's say for example data labeling, cleaning of the data, and all of those things. There's going to be a lot more jobs being created around these spaces in order to get these models to production. So, but the most use cases right now, what we're seeing is in customer support, insurance underwriting, and also various things in which processes and efficiencies can be made better within organizations. So these are a few of the use cases. But the thing here right now is there's a lot of choice in which developers can use, and this is something which is pretty overwhelming. So if you go to Hugging Face or even many organizations like GitHub, even they have their own model repository and consumption repository. There are many things which people don't know which is the right model to use for what use cases. And in most of the cases, they're not using the large language model itself. They start off with large language models, find the domain in which they're working, and then they end up using a domain-specific model after evaluating all of these large language models. But then again, to run these large language models, there are different ways. We are showing one of the way, but there are many different patterns. Like say, for example, there are other popular tools like Olama, there's Replit, and there is things. It lets you develop your applications locally, but then if you want to take it to production or containerize that, again you need to build the skills and build the tooling out there. So Podman Desktop kind of abstracts that anyway you're going to build your applications locally within your workstations. So you need a way in which you can interact with these models, and depending on what kind of infrastructure you want to take it to, it comes with all the built-in tools and the things. We also have a workshop on it tomorrow post-lunch where we'll be doing the similar exercises. Yeah, and this is one of the things, and we already have started seeing the impact of this. If you're seeing how the stock market prices of large chip manufacturers which have crashed ever since the DeepSeek results came out, it's one of the things right now. There was a cycle of hype and expectations and all of that, and right now we are going through the plateau phase where people are figuring out the noise from the actual signal in various things. Like say for example, right now they have shown that you don't need enterprise grade GPUs or you don't need enterprise grade infrastructure in order to build a very good model. DeepSeek has shown that, and Red Hat and IBM have always been saying that these small language models are the way to go instead of these large language models, because running large language models require a lot of compute and a lot of planning in order to take it to production. And most of the organizations have already invested in their hardware capacity cycles. And there is also this demand of you're not getting the latest GPU, you're not getting the latest hardware or the latest gigabit internet switches in order to run your problem. So there is this artificial demand also which has led to companies being more and more innovative, right in terms of the hardware design to how they want to take this problem to production. So right now what we are seeing is a plateau of consolidation, and then it's going to plateau out, and then again people are going to start adopting it for the enterprise applications where people are willing to pay for the problem. So if you take a look at most of the internet, like Reddits and all of that, most of the ideas are great, but not everybody are willing to pay for those ideas. So the enterprise companies would look at models, if a model can be supported for a longer period of time, and they also give them the autonomy to run their own models by themselves, where their data is also secure for them. They don't want their data to be trained on third-party models. Like say, for example, if you're an IT ops organization, you're trying to adopt incident response or like those things, they don't want to expose that kind of a data to a third-party organization, and especially that organization is not within your geographic boundaries. So even that's one of the reasons why if you see the US, the US White House directives and all to say no using DeepSeek within our data centers, no using various things. So as a developer or as an architect, you always need to be flexible with what kind of output you're looking from a particular model, and there are many techniques and tools for that. And the choice of using a large language model is also very critical. So recently I heard this phrase saying that choosing a large language model is like choosing a partner of a dating website or a matrimonial website. Everything looks exciting in the initial testing phase, but then even when you run it in production, that's when you start seeing the real issues, and you're stuck with that model. You can't do anything about that model. So these are a few of the things when you start adopting these models, you're going to see the flip side of using that particular model which has been trained on old data. But then again, developers are the most impatient of and the most lazy of the people in the IT industry. They have come up with their own ways or own patterns. Like how many of you have heard about design patterns from object-oriented programming, where they try to group problems in various design patterns? In the same way, AI patterns are emerging. Like say, prompt engineering is one of the patterns, and another pattern is retrieval augmented generation, the RAG. And now you've been seeing a combination of RAG with agenting. Because if some side of the tool is giving inefficiencies, the other side tries to be more efficient by consuming these models. So the developers have come out with their own patterns to work with the limitations of large language models. But that's a different topic and a different field altogether. But these are some things which you need to keep in mind. So, yeah. Unfortunately, generative AI can't solve AV issues. So, yeah. And this talk is, like I said, mostly focused on application developers or SREs who are working with their local laptops trying to get these applications to work. So these are few of the areas in which most of them would be doing or you would already be doing. Like one is evaluating what is the right LLM for you. So if you go to Hugging Face, now there are hundreds of LLMs. Not only large language models, there are domain-specific models. The domain-specific model could be working with financial data, working with image data, working with geospatial data or like agricultural data, all of those things. And then you're going to try out some prompts. So most of the organizations have some kind of a LLM evaluation criteria where they it could be as simple as where they put all the kind of prompts they're going to give to a particular LLM, and they're going to write down the output of what they're expecting, and then they benchmark these large language models against what output they require. But if the organizations have access to enterprise grade GPUs, then their evaluation is totally different. Because one of the things about large language model is it's probabilistic in nature. Your answer may or may not be correct, right? But most of the use cases, what you're seeing out there are deterministic in nature. Will this person get the insurance or no? Right? So you're trying to fit in a technology which is not inherently giving you a deterministic output, but by design it is probabilistic in nature. So if you apply logic, usually you put deterministic systems to get a deterministic output. But right now you're working under the constraints where you're trying to fit in a probabilistic technology for a deterministic output. Like if somebody's fingerprint doesn't match, will he get the full ration or no? Okay. We can't say I'll give you 60% of the ration because 60% of your fingerprint has matched. Right. So these are the kind of problems as an engineer you need to keep in mind while using AI into the system, and that's another topic where you come out with the ethics and the biases and all of those various things. But from the application point of view, along with these large language models, you're either trying to connect to a data source or you're trying to see some kind of error which has come and try to feed that error back into your knowledge bases and see what would be the outcome of that. And then Another popular method, I think this is waning down right now, is something called chaining, where you're taking the model's output from, let's say, a ChatGPT and running it through Gemini, and from Gemini you're trying to run the output through Claude and see if there is consistent results from each of these things, and take the output of one LLM and pass it through another LLM. These are a few of the ways. And the other thing is you're evaluating flows. How close can I keep the data set, the training data set? How can I minimize both from the compute and also from the business process perspective? What would be the right flow for me to take it to production? And then again, operationalizing. So most of the folks are stuck here. Getting this one to production is where many people fail, right? So because this is an easy problem to solve. This is a low-hanging fruit. But this is a complex problem, because now you need to take these models from your laptops or from your local workstations and take them to production environments, either on any cloud. Like, so it could be your hyperscalers, AWS, Google, or also your private clouds. So this is where again there's a huge skills gap. How do we do it? Do we take the Kubernetes route? Do we take the VM route? Or do we take bare metals and just install these models and take them to production? Again, it depends on the scale and the type of problem you're trying to solve. But these are few of the patterns in which you're trying to take into production. So there was a survey done by Gartner in which the reason why AI applications got very popular, if you see over the last few months, we take a Product Hunt or G2 or any of these websites, we have thousands of AI applications being written. Are most of these developers proficient in data science and deep learning? No, they are not, because the number one way they are consuming so the number one way in which they're consuming most of these AI models are through an API. So as long as the developers are given an API, or a data scientist is given an API, they're not bothered what is the underlying model. They're going to hit number of requests to it, or group their requests and hit it together to get the output. But like any of these SaaS solutions out there, coming out to the initial prototype is easy, but taking it to production with refining your things, that's where many people are stuck. So these are a few of the things. And the cost of running these large language models. Not every organization can build a large language model. You need significant amount of compute. Like say if you take a look at the fastest supercomputer right now to build a large language model, it's with Twitter or X.AI. They built a new computer called Colossus, which they came out with Grok recently, as recent as last week. Very few organizations can build a large language model. Like Meta, IBM has its own supercomputers, with which Red Hat builds the other models. So one of the reasons is the amount of data you are putting in and the amount of training you have to do on that kind of data. And you could also see like one famous organization scraped ebooks from torrent in order to train that model, and they were pulled up last week. Right? So how are you getting the data? So when you are talking about open source models which are taken to production, it's not just you can use the model freely. What is the code used for making that model? What is the training data sets that trained on? And how are you using that model? Can you use that in production use cases, not just for playing around? So these are all the various factors which the developers and the architects and all will need to keep in mind. And like say the easiest way to consume is by using tokens, but many organizations frown upon this, especially the enterprise organizations, because they don't want to be connecting to third-party web services and all. Like say, many organizations within your policy, it's not the legal and the compliance team are going to stop you for using any of these tools, because nobody knows what kind of data is being collected and how the data is being used. And most of the so-called open source large language models are just freeware. They're not really open source because they don't talk about the data. They don't talk about the weights and the distributions used in their parameters to run their applications. So these are the kind of costs which, when you're discussing with customers, or you want to start your own generative AI project, these are the initial cost of the experimentation, development test, and also paying the subscription and the recurring costs and monitoring those, what kind of requests you're seeing, what kind of consumption you're doing all of the hardware. But even after doing all this, if you're not getting the results by using generative AI, that's the worst case scenario, because even after doing all this, many of the organizations don't get the desired results. So that is the reality in which most of the organizations are living right now. So what I wanted to say, touch upon is one of these back of the envelope calculations, because now it has become critical, saying that like somebody is going to ask, can I use generative AI to solve this problem? Now your calculations will start in various ways. You need to understand the basics of what is exactly happening with the large language model. So I just want to touch upon three major things which you have to know. So one is you need to understand parameters. So if you go to Hugging Face, you will find models, like say for Llama or like the Granite models. So you will find various terms like 8 billion, 14 billion, 400 billion, 500 billion, like few of these models, right? And the second thing is, so basically the first thing which you need to understand is parameters. Is it legible? Okay. So, the better parameters means the model is usually better, and it also requires higher capacity to run. And usually you can find models in FP32, which is of the highest grade right now. Okay, but the highest FP32 is the high accuracy and the largest memory footprint model. If you see any model with FP32, that means it's using 4 bytes per parameter. And now you need to start calculation. There are a billion parameters, 8 billion parameters. So you need to do the calculations back of your head. And then the second one is FP16, which is half precision. It's a good balance between the parameter consumption and the memory. So these are 2 bytes. The ones which we use in consumer hardware is the int8 and int4 or even lesser, right? So these are a few of the quantized models. So quantization is one of the important things which you need to, it's basically a trade-off of what you want to use and how do you want to use these models. And then the way you calculate the memory is the number of parameters into the number of bytes of parameters. So this is a consumption which you need to, I'll show you an example. Say for example 8 billion parameters with FP16 memory is about 16 GB of RAM. This is how your calculations need to be, because what's happening right now, especially the newer architectures which are coming out from Apple Silicon, AMD, they're coming out with unified architectures where the CPU and the GPU memory are on a single board. And this is how you kind of calculate the model. Like say for example, if you want to run the 400 billion parameter in an FP16 accuracy, this is like the Llama 400 billion parameter, you need a video RAM memory of 745 GB VRAM. Okay. So now you need to take a trade-off. You want so much accuracy, so much models precision. So this is something which you need to keep in mind. So these are a few of the back of the mind calculations.
Cool. So how do we solve this issue? One thing is, as a developer, let's try to run these models locally. Now, what advantages do we have when we try to run this model locally? First, for developers, is it gives me a lot of convenience. I don't need to go to my UAT or production and then have one more GPU EVM there, then expose it, then use it locally. So, workload. What I do is I try to set it up locally, use it locally. Second thing is ease of integration. It's very easy for me to do things locally rather than doing a combination of doing it locally and then doing it on the UAT. And third is customization. Customize the way I want. What I can do is I can maybe, like, while deploying a certain model, I can change the number of max tokens that I'm giving. I can change if I want to enforce it, how do I want to, what to run, how do I want to, if I want to offload some of that, the load that it has from the GPUs to the CPU, everything that I want, I can do it locally. Now for organizations, how does it make it better? Number one thing is security. It's highly secure for organizations to enable the developers to run their models locally. Second thing is cost. Organizations don't have to spend much on the costs of developers, like enabling developers to develop and use these models locally. And at the end, our legal team is very happy if we are able to use this locally. But how do we use it locally? What are the tools that we have currently? Number one is you can use something like a VLLM server and then just get an endpoint out of it. You can use Ollama. But let's look at what Podman does. How is Podman it? So what is Podman? Podman is a tool that makes your life easy with containers. What Podman also does is Podman has AI Lab AI Lab. So what Podman we'll go through what Podman AI Lab has. First thing is generative AI recipes. If you look at common applications of generative AI, RAG, text summarization, chat applications, all of this, Podman AI gives you the generative AI recipes where you have everything, all the base code, everything integrated. Next is model catalog. Podman AI has a ton of models already that is available with them, where you can just download them and use them. Licenses are there's a clear information of the licenses used. Once you use this model, you get an open API compatible endpoint out of it, which you can use to develop applications on top of it. And at the end, let's say if you don't want to integrate, you just want to test these applications. We have playground environments. In playground environments, what you do is you just pick a model, you download it, you host it, and in these playground environments, you can test with these models. What you can the good thing about these things is you can also vary the parameters that you're giving while inferencing the model. Let's say you want to update the match tokens, you want to update the temperature, you want to update the top key, you want to see, you want to update the system prompt as well. You can do everything in a desktop applications using that.
Yeah. So I think we are already like out of time. So what? I'll quickly show the Podman Desktop AI Lab, like how it looks like and how you can go ahead and check. Tomorrow we are going to have workshop where we are actually going through like deploying either RAG applications or even with the normal LLM model, and then try to how to access it and how to make query about it. So
Podman Desktop is freely available. You can
Yeah.
go to podman.Desktop.ai, download the model download the application from Windows, Mac or Linux.
Yeah, and then once you download it, there's something called extension. So you have to actually install the extension. So this AI Lab is kind of extension which you have to install it first. Once you install it, then you can see here is the recipe catalogs. We have different recipes like chatbox, RAG, and then summarizer. There are a lot of recipes. And even if you go and check the catalogs, then we can see that a lot of models are available. And like Ram was talking about like 8B or 7B, like, and then mostly the good thing is that you can even see like how much RAM it's supposed to or going to use in this site, and so that as per your hardware, you can see okay which model I can run it locally, and then you can run it and then start the service for it. If you see the import, then you can actually, if you have built your own model, right, you can actually import that particular GUF file, and then you can use that model for starting as a service. So mostly use it the inference service, right? So you can actually use any model, and then you can check the services. Once you have like the model, you can start the service, and it will run as a container and then give you the service endpoints. And then there is a playgrounds are there, which actually connect to the service here in the Podman Desktop UI itself, and then you can actually ask the queries and do everything from here itself. So, yeah. So I'm going to stop here. We'll anyway we are going to have the
If you're working with a chatbot and you want to experiment with many models in the backend, it comes with built-in base applications on which you can build your own application on. So they are all the AI recipes, and all of these are open source. So you can download from the catalog, and then, like say, for example, if you just start it.
I don't have.
Okay, sorry.
Yes. No, I'll just one second. So there you can see the source code. If you see like what this recipe is and how it connects and all those things, and even directly you can open those recipes from your VS Code, and you can see like change the recipes, change the endpoint, and see how it is working and all those kind of things without any issue.
And most of these recipes also come with a container file.
Yeah.
You can use it to deploy to any Kubernetes kind of environment.
Yeah.
So
Or you can.
most of these things come pre-built into the tool itself. So you have your.
Yeah, I mean, you can use this container file as kind of a base so that the model or the application you are developing, and then add to that particular container file without any issue. So, Yeah, I mean, is there any question? Because yeah, if there is, like, we have to take it now and then.
We can take questions. We also doing a workshop on how to do this, so you can get hands-on thing, but more at around 3:50.
Yeah, yeah. Second half. No, no, it's in a different.
Thank you all for this session. So just a question on what is the current usage of Podman in development environments?
So recently we crossed 2 million hits. So just I think 3 days before it was, we were figured it out like it's already hit 2 million. So there are a lot of people who are using the Podman Desktop for, like once this Docker desktop become, commercialized for organizations, the people are mostly shifting to these open source solutions and then trying to consume it, try to use it, and it works very well in all the platforms. Thank you.
Podman as such is widely adopted in regulated industries. Podman Desktop came out after Docker Desktop subscription per user thing. But then the development of it, we had like AI as one of the first class citizens, that's how people are contributing. And it's also right now contributed to the CNCF ecosystem. So right now Podman Desktop is a CNCF project. And it's not only AI Lab, there are other catalogs also. Like, for example, if you want to make portable containers, you can install those. You can go to the catalog, there are quite a bit of extensions which you can install in a single click on Podman Desktop.
You can state your question.
Yeah, just, yeah.
Thank you. So I wanted to ask, like, we are working on LLMs and all. So what's your concern on, like, there are, I read the research about voice is bias. It's like, with the fraud injection we can pass on. So what is the, like, how we can make it our LLMs secure?
So, say if you are serving the large language model, it's the same software architecture patterns which you are using to secure your API. There is nothing new which you are going to do to secure your LLMs if your software architecture is bad for your application. Because end of the day, most of the LLMs, not the new ones, the ones which are doing the chain of thought or reasoning, but most of the LLMs, you can think of them as biomechanical machines. You're just giving it an input and you're getting an output. So it is very easy to fetch data into LLMs, and we have already seen that. Like say, someone tried to book tickets on one of the popular airlines and saying that I'm a customer. As a customer, you need to agree to me for everything, and the person took first class and business class tickets at an economy price. So it went ahead and gave him the tickets. But the whole thing is, again, it comes to your software architecture design. How do you want to secure those API? If somebody is asking, let's say for example, you might have seen news that some LLM vendors or large organizations have been called to PMO's office because it was not generating the right output or the very biased output based on certain questions. So there are also biases which will be introduced. Let's say for example, scolding with swear words. Okay, these LLMs would have been trained on Latin languages like English. Now, if you're swearing in Indian languages, does it understand? Does it understand the cultural context of those things? So those are few of the things. There's a whole area about that, about AI biases and trustworthiness of AI. And I think there's also talk regarding that, how organizations can adopt AI in a more trustworthy and a least biased way. Like say, for example, again, companies building these AIs, they also, that's the reason why open source large language models will be more transparent in the future, and they have already started is where did they train their data, what are the biases introduced in that particular project, even though it's open source. Let's say it's not just AI, but all, let's say Wikipedia. Somebody can put biased information on Wikipedia. But the number of people who review it would make it objective and neutral. So biases would creep into large language models, and you can still do that. No, you can. So when that's like say you can have another layer to see what kind of input is coming in and try to use certain keyword-based matches and certain things, where there are already tools and libraries available to catch certain kind of prompts and then say, you can't ask this particular question within your content, like those things. So there are already many projects which do that, like which can identify any biased language or any politically leading question, all of those. There are many projects which are out there which can identify the tone of the prompt and also protect the. Thank you.
I think we have
Okay. Yeah, I think.
one more question. This is a very interesting and never.
How can we make use of Podman Desktop to create small LLMs? Because the industry itself is shifting towards small LLMs.
So you can't use it to create small LLMs. You can use it to deploy small LLMs locally and then work with those small LLMs.
Like you can train it.
So if you go to Hugging Face, you can see models in different formats, like the Int 16, the 4 billion parameters 16. So you can figure out what is the size of your laptop or your machine, get the right sized model locally, and run it with your application. So you can download it if you're using a Mac or something. You can use the GTO format, or if you're using a Linux virtual machine with a GT, you can use other formats. But building it was very difficult. There is another project called InstructLab. There is also for building large language models locally. It is a different thing. It is very difficult to build it with consumer grade hardware.
You can mostly improve it, like
Yeah, you can
use with the small set, and then you can improve it, like according to your needs.
Yeah, let's say there is another open source project called Exocluster. That is, so you can take a bunch of these, let's say Mac minis or the new computers which are came out, like the NVIDIA digit computers, or even Raspberry Pis can be chained, and then you can use them as a cluster. And you can take a large language model. It's not going to download the whole thing. Like say, for example, if you require almost 1 terabyte of video RAM, what it's going to do is going to download the model and distribute it across a cluster, and then you can run it locally. So, I mean, that's a nice project which you mentioned, the Exocluster project.
Thank you.
The only problem with unified architecture is within that system, the consumption would be very fast. So where the consumer hardware can never beat the enterprise hardware is the networking. Because in your consumer hardware, the maximum networking you'll get is a 10 gigabit network. But the ones which are coming in the enterprise grade, which data centers consume, let's say on an average, the networking speed will be 400 gigabit. Or even Juniper is making these machines with 800 gigabit. So distribution of these things. But if you're doing it with Mac minis or something, maybe Thunderbolt 5 can get you up to 80 gigabits per second. And the other thing is it's practical. Like say the NVIDIA A100 card, one of those cards, just the card is around $10,000, right? So whereas a top spec Mac Mini Pro, which is like the basic of the hardware, you get it at $2,000. And now that one comes with 64 GB RAM. Even that one comes with 64 GB RAM. So the consumer hardware, and if you're efficient about it, you can build local mini clusters within your organizations. And that is where I see many of the organizations building their own mini clusters within their own premises, and which is budget friendly also. To do experiments, you don't need enterprise grade hardware because, again, like in every year, NVIDIA releases the price of the GPUs, and the cost of the GPUs keep falling, but the efficiency keeps increasing. So that's
Yeah. Thank you. Thank you.